Hello, welcome to another CASIM video tutorial series I'm running on Arduino, Pure Data and Super Collider and related topics. We've built our own Arduino on a breadboard. Now we need to get that data from the sensors into Arduino. And we're going to do a number of things. First of all, we just want to test that the sensors are working okay. If we go up to Tools and down to Board and Port, the microcontroller should show up as either a Genuino Uno or a Due Millenove, Arduino Due Millenove. In a couple of instances I've had to use Due Millenove, but this one has a Genuino Uno bootloader on it. So we select that, and then the dev TTY USB 0 is the port that we use to talk to it. So I'm going to just capture the FSR data. So we need to define some variables. So hash define FSR1, and his port number or pin number is 5. It's actually microcontroller pin 28. That corresponds to analog input 5. Then I'm going to do the same thing for the other FSR. And that is FSR2, and it's going to be on analog input 4. We need some variables as well. As an integer, I'll say int val1 and val2. Those are going to be the readings. So we end that declaration with a semicolon. I can hear the bin lorries outside. So initialize serial communication, serial.begin. There are a number of baud rates available. I'm also going to be using these LEDs later on, so I can put something in the code there, but I might as well do it now. I need to ensure that the pin mode of 9, which is the first LED, is set to output, and then the pin mode of 10 is set to the same. So pin mode 10 is output as well, because we're going to be sending pulse width modulation signals, fake analog output on those two PWM pins to control the brightness of the LEDs. Next, that's all we need to do in the void setup routine. This is a routine that runs once, or a function that runs once. Now our loop is where we do our reading. This loop function runs continuously. So value 1 is going to be analog read pin FSR1, and val2 is going to be analog read FSR2. I want to output those values to the serial monitor just to test, so I will do serial.print, and I'm going to print value number 1, serial.print, I'll just put in a little space there, the symbols, and serial.print ln, carriage return line feed, value 2. So it's all nicely readable in the monitor window, and then a delay just to avoid overloading the microcontroller. Delay 10. And I can upload this. I'll just save it as that. Uploading, done uploading. Click the serial monitor window, and that one's ranging between 0 and about 1,000, and that's slightly different. It's about 20 to 700. So that's the values we're getting. And we know it's working.